Hey guys and girls, so in today's video I'm going to be showing you how to make your character fly. To get started, inside of Starter Player, Starter Character Scripts, I'm going to create a new local script and delete this first line here. The first thing I'm going to do is use the Context Action Service to create a key input and a button for mobile phone users. So if we go down to the functions, we can see there is a function called bind action, and what this function is going to do is allow us to bind a key input and a button to a function. And after binding a action, I'm going to use the set position function to position the button, and I'm also going to use the set title function to set a title for the button. If you wanted to, instead of setting a title, you can also set an image for your button if you wanted an image instead of a title. So let's first get the Context Action Service. And let's now create a function that the action is going to call. And for now, I'm simply going to print the input state. So print input state. And now let's bind this function to a action. So this action has a ID of fly, and I'm binding it to the fly action function. I'm passing true because I want to create a touch button, and I'm also providing a key code which key I want to activate this function. So I want the F key to call this function. Now let's play the game. So if I now press the F key, we can see that input state is begin, and if I release the F key, we can see that input state end. So as I press the F key, we can see the state goes from begin to end. Now if I go into mobile phone mode by pressing this small button here and playing the game again, we can see that we have this weird button on top of the jump button with no text or image inside of it. And if I press this button, we can see we have the same printout as the F key. So if I press the button down, it begins. If I release the button, it ends. So now let's set the button's title and also the button's position. So you can see I'm using the same ID as when I binded the action here and here. And I'm setting a title to be called fly, and this is where I want to position the button. And now if we play the game again, we can see that the button has the title fly, and it's moved off of the jump button to the left of the button, and now I can press it over here. Now what I want to do is when we toggle flight mode on, we're going to use the run service to connect a function to the heartbeat event. So the heartbeat event fires every frame after the physics simulation has completed. So the first thing I'm going to do is at the very top is get the run service. And then I'm going to create a variable called connection, and I'm going to set this variable to nil. Now currently this fly action function is called twice once when the F key is pushed down and once when the F key is released. But I only want this function to be called when the key is pushed down. So to prevent this function from continuing when they release the key, what I'm going to do is say if input state is not equal to begin, then I'm going to return out of this function, exiting the function early. When we return out of a bound action, it's possible to pass two values into this return statement. So we can return a context action result, and we have the option of pass or sync. And if you want to know what this does, we can read this here, but I want to pass the function, so I'm going to come to this return and I'm going to say enum context action result dot pass. I'm now going to use this connection value to determine if we're in flight mode or if we're not in flight mode. So I'm going to delete this print and I'm going to say if connection equals nil, then and else. So if connection is nil, we're not in flight mode. If connection is not nil, we are in flight mode. So if we're not in flight mode and we've just pressed the F key to activate the flight action, we're going to connect the connection. So to do this, I'm going to say connection equals run service dot heartbeat connect, and inside of this connection I'm just going to simply print HB for heartbeat. But if we've pressed the F key and the connection does exist, meaning we're already in flight mode, I'm going to disconnect the connection to exit flight mode. So I'm going to say connection disconnect, and I'm then going to set connection to nil. So if I play the game now, and if I press the F key, we can see that the HB starts printing every frame, and if I press F once again, the connection is disconnected and it stops printing. And the same is true if I press this button. So if I press the button, it starts printing HB, and if I press the button again, the heartbeat is disconnected and it no longer prints. Now let's create a vector false. This vector false is going to allow us to apply a false on the character in a certain vector. So let's first get the character and the character's primary part. And inside of our local script, I'm going to create a vector false, and I'm going to set enabled to false, and I'm going to set the false to 0, 0, 0, and I'm going to change relative to world, so the false is applied in world space. Now let's get a reference to the vector false. So I'm going to say vector false equals script wait for child vector false. I'm then going to set the attachment value to the primary part's root rig attachment. So if we play the game inside of workspace, and if we look inside of my character, we can see the local script, the fly script. We can see that the vector false. We can also see the attachment is attached to the root rig attachment. And if we look inside of the root part, we can see that the root rig attachment is this attachment over here. So now we have our vector false. Inside here, just before we create our connection, I'm going to enable the vector false. So vector false is going to be set to true when flight mode is activated, and when flight mode is deactivated, I'm going to set vector false equals false. And to test if our vector false is working, I'm going to come into the properties and change the false y-axis to 5000. Now this value may be different for your character because every character has a different weight, so you may require more or less force to push your character up, but for my character 5,000 is enough. And if I press the F key, we can see that my character starts going up. If I press the F key again, we can see that my character starts going down. And we can also see that while I'm flying, I still have control over my humanoid. But we don't want the humanoid to control the character. So I'm going to use the change state function, and we're going to change the state to physics. And what this is going to do is say the humanoid doesn't apply any force on its own, and now we will have to manually move the character. So after we have enabled the vector force, I'm going to say character.humanoid change state, and I'm going to set the state to physics. And once we exit flight mode, after I have set enabled to false, I'm going to exit the physics state, and I'm going to set the humanoid into free fall state. So if we test the game again, when I enter fly mode, my character now starts spinning out of control because the humanoid is no longer controlling the character, and I no longer have the ability to move my character around. So in free fall I can move my character, but in fly mode I can't move my character. To prevent the player from flipping out of control, we're going to use align orientation to make our character rotate in a specific orientation. So now let's create our align orientation, and we do this the same way we created the vector force. So I'm going to come into here and create an align orientation, and I'm going to set enabled to false. I'm going to change the mode to one attachment mode. I'm going to set the max torque to infinite. To do this, I'm going to copy the infinite value from here and paste it into here. So now they're both infinite. And I'm going to set the responsiveness to 30. Now you can play around with these settings to achieve a value that you desire, but these are the values that I like. And now I'm going to do the exact same thing that we did here, but for the align orientation. So I'm first going to get a reference to the align orientation, and then I'm going to set attachment 0 to the primary parts root rig attachment. And when flight mode is enabled, we're going to enable the align orientation, and when flight mode is disabled, we're going to disable the align orientation. So if we fly again, we can see that our character does not flip out of control, and for now it just always rotates the character to point in the forward direction. So if I'm looking this way and I enable flight mode, he rotates and looks over there. If I look this way, he rotates and looks over there. Now instead of blindly pushing the player up into space, let's make the character float. So I'm going to select the vector force, and I'm going to change the force back to 0, 0, 0. And now if we look inside workspace, and if we look at the gravity property, we're going to use this property to make the character float. So I'm going to first create a vector free called gravity vector, and I'm going to store this gravity value in the y-axis so that we can push the player up. While playing the game, if I look inside of my character, for instance, if I look at the left hand and scroll down, we can see that there is a property called assembly mass, which is 15.7, and if I select a different part, we can see it has the same mass. And if I, for instance, make the left hand more dense, so if I say custom physical properties and if I set the density to, let's say, 10, and if I select any part in my character and we check the assembly mass, we can see that the mass has increased to 18.8. So depending on the character, or if the character is holding a tool, or if the character has any accessories, the mass of the character will constantly be changing. So we need to make sure that we account for this when we push the character up. So inside of our heartbeat function, I'm going to write vector false dot false equals gravity vector, and I'm going to multiply it by the assembly mass. So if I test the game again, and if I enable fly mode, we can now see that I start to hover, and I can't move while I'm hovering because we are in physics mode, and no matter what my density of my character is, or if I'm wearing any accessories or have any tools enabled, this force will always be perfect and make sure that my character floats perfectly. The next thing you'll notice is there is no drag. So if I run and jump and enable fly mode, you'll see that my character starts moving in a direction and never slows down and keeps moving forever in that same direction. And that is because Roblox's physics does not have any drag. So to add drag, I'm first going to create a new variable called drag, and I'm going to set it to 1. The next thing I'm going to do is make sure that the character's velocity is greater than 0. So I'm going to say primary part linear velocity dot magnitude greater than 0. Now if we look at the drag equation, we can see that the velocity needs to be squared. We're not going to bother with reference area, and we're going to move this 2 into the coefficient. So the main thing we're going to need is the velocity squared. So I'm going to create a new variable called v2, and I'm going to get the linear velocity and I'm going to square it. Now let's work out the direction the drag needs to push in. So to calculate this, I'm going to say local drag vector equals, and I'm going to use the velocity, and I'm going to unit the velocity, which means to set the velocity's magnitude to 1, and I'm going to subtract it so that the drag is pushing in the opposite direction of the velocity. So now that we have the direction the drag is going to push in, and we have the velocity squared, let's add this force to the vector force. So I'm going to say vector force dot force plus equals drag vector times, now if we look at the drag equation, first we're going to use the coefficient. So here we have our coefficient value, which we've stored in the drag variable. So I'm going to multiply it by drag. Then we're going to multiply it by the density. So that is the assembly mass. And then we're going to multiply it by the velocity squared. I'm now going to delete this HB print because I no longer want to see it, and I'm going to play the game. And if I run and jump and activate fly, we should notice that drag brings my character to a stop. So I'm going to run, jump, press fly, and my character comes to a stop. And by adjusting the coefficiency of the drag, I can change how strong drag is on my character. So if I change drag from 1 to 0.1 and play the game, and we should now see that it takes a lot longer for my character to come to a stop. So I'm going to run, jump, fly, and you can see that my character is drifting. And you'll also notice that at very low speeds it takes a very long time for my character to come to a full stop. So while squaring the velocity, so let's imagine x is the velocity and we square it by multiplying it by itself, we can see that at very low speeds the drag is almost zero, so the character can hardly ever come to a stop. So even though this is true to real life, we may want to adjust this curve to fit our needs. So instead of having x to the power of 2, we could have x to the power of 1.5, and now you can see that the curve is not as strong as if we square it. And we could even reduce this value even more to have even less, or you could even have just a straight line like this if you wanted to have drag be a linear function. Now I'm going to use a value of 1.2, so let's set this to 1.2. So we can see that for the blue line, at low speeds we have more drag, but once the character moves quickly, now the blue line has less drag than if we had squared the velocity. So more drag at the start, less drag at the high speeds. So to make this change in our script, I'm going to simply change this 2 to 1.2, and in order to make up for the less drag that we're going to see at high speeds, I'm going to increase the coefficient to 0.5. And if I test the game again, so I jump and start flying, we can see that our character comes to a full stop a lot quicker than it did before. And if I fall down a little bit, and we can see that the character doesn't drift for as long as it did before, and now I've come to a full stop. I'm now going to change how this code is written slightly. So instead of multiplying the velocity v2 down here, I'm going to multiply it up here like this, and I'm going to delete this line, and I'm going to delete this from here. So this has the exact same outcome, but it's just written slightly differently because this is how I like to write this code. And there's one small thing that I forgot to add. When we return the pass value here, I also forgot to return the pass value at the bottom of the function. So let's make sure to return the pass value here. Now let's add the ability to move the character while flying. So the first thing I'm going to add is a new variable called false, and I'm going to set this value to 400. I'm now going to use the humanoid's move direction vector 3 to determine the x and z axes the character wants to move in. So I'm first going to store this vector 3 in a variable called moveVector. I'm then going to check the magnitude of this move vector to make sure that it's greater than 0. And I'm now going to add this move vector to the vector false. So I'm going to say vector false.false plus equals move vector times our false value, which is 400. Currently we're setting the false to 400, and whether a character is heavy or light, the false is always the same. So this will result in lighter characters flying faster and heavier characters flying slower. So in order to normalize the speed so that all characters of all sizes fly the same speed, we need to make sure to multiply it by the assembly mass. And if we test the game once again, and if I start flying, I can now use the D-pad or my WASD keys to fly around. And we can see that the terminal velocity of the character is kind of fast, so we can slow the fly speed by increasing the drag. So I'm going to increase the drag from 0.5 to 1 to reduce terminal velocity. And now my fly's max speed is a lot slower than it was before. So feel free to play around with the force, the drag, and the 1.2 curve value to achieve a fly feel that you like. Now let's add the ability to fly up and down. So I'm going to create a new variable, and now I'm going to create a new action. So let's first create the function for this action. So I'm creating a new function called up action, and inside of this function I'm going to check if the key was pressed, and when the key was pressed I'm going to set the y-axis to 1, and when the key is released I'm going to set the y-axis to 0, and I'm also going to make sure to pass the function. And now let's bind this function to the space key. So at the bottom I'm going to bind the up action, and I'm going to set the title to an up arrow and position the button to a place that I like. So if we test again, we can now see we have a new button with an up arrow, and if we press this button nothing happens, and even when we're flying nothing happens, because all this button is doing at the moment is setting the y-axis value from 1 to 0. This is also a good time to find out what this pass value really does. So we can see that I'm using the space key. So if we play the game, and if I press the space key, I can jump. But if I change this pass to sync, now this is going to sync and prevent the space key for working for the jump. So let's play the game again, and if I press the space key now, nothing happens. I'm no longer able to jump because the action is syncing the function. So it's important that we set this value to pass so that we can continue to jump if we use the space key. I'm now going to create another action, so let's copy and paste this function, and I'm going to call this down action, and instead of setting the y-axis to 1, we're going to set the y-axis to -1. And now let's bind this down action function to a new action. So we now have a total of 3 actions. One is the fly action, which requires you to press the F key, the up action, which requires the space key, and the down action, which requires you to press the left shift. And if you play the game, you should notice we have a total of 3 buttons: the fly button, the down button, and the up button, which currently do nothing. So now let's make the up and down buttons work. So I'm going to come over here where we set the move vector, and I'm going to delete this part where we set it directly to the move direction, and I'm going to set it to a new vector 3, and I'm going to use the move directions x-axis, and I'm going to use the move directions z-axis, but I'm going to use the y-axis value that we have here to set the y-axis. Because we're adding the move direction and the y-axis to the same move vector, if we try to fly up and in a direction at the same time, the magnitude of the move vector will be greater than 1, which is not what we want. So we need to make sure that we normalize the move vector so that the magnitude is not greater than 1. So to do this, I'm going to come in here and say move vector equals move vector dot unit, and this is going to make sure that the magnitude doesn't get greater than 1. And we should now see that if I press the up button or the down button, I should be able to fly up and down. And if I press the space key or the shift key, I can fly up and down. Now that we've finished the vector force, now let's work on the align orientation. So when the move vector is greater than 0, we're going to adjust the align orientation. So to do this, I'm going to come down to here and I'm going to say align orientation dot C-frame equals, and I'm going to create a look vector and it's going to be set at 0, and I'm going to use the move vector to determine the direction that the character should look at. So if I fly, and if I fly to the right, my character looks to the right, and if I fly to the left, my character looks to the left, and if I fly forward, my character looks forward. Now there is a small problem. If I say I'm looking to the building over there and I stop flying, and if I move my character over here and I activate flying, my character will rotate to the previous saved orientation. So to fix that problem, before I enable the align orientation, I'm going to set the C-frame of the align orientation, and I'm going to make it have the same C-frame as the character. So now if I look in this direction and I activate flying, my character stays looking the same direction, and if I point towards the buildings and deactivate flying and rotate my character and then activate flying again, my character stays facing the same direction it was facing as I pressed the F key. Now I want my character to fly head first in the direction he's flying, so I'm going to rotate this look vector by 90 degrees on the x-axis. So here I'm rotating the character by 90 degrees on the x-axis, and now my character will fly head first in the direction he's flying. We now have another slight problem. When flying up or down, the character will always face in the same direction. So if I'm flying to the right and then I fly up, he will start looking to the left. And if I fly to this way and I fly up, he'll still look to the left. So this can make the rotation act kind of weird when going up and down. And the same for the down axes. If I'm facing this way and I go down, it looks okay, but if I'm facing this way and I go down, it kind of does a roll and always looks towards this direction. So if we look at the look at constructor, we can see that we're using the move vector to calculate the C-frame, and if we look here, we can see that we're using the move vector as the look at vector. And we can also see that there is a default value for the up vector, which is set to 0, 1, 0. So when the look at vector and the up vector direction align, then it's no longer able to calculate the C-frame correctly. So we need to make sure that the look at vector and the up vector stay different from one another. So in order to know if the player is flying perfectly up or down, what I'm going to do is say if math.abs moveVector.y equals to 1. So what that means is, because we're setting the max magnitude of the move vector to 1, the maximum this y value could be is 1. And if it's 1, that means we're moving perfectly up. But because we're doing math ABS, what that means is we're changing a negative value to a positive value. So if this is -1, it will also equal 1. So if the player is flying perfectly up or down, we'll go into this section of the if, but if the player is not flying perfectly up or down, we'll go into the else. Now I'm going to cut and paste this line of code into the if and the else. And if we are flying perfectly up and down, I'm going to change the up vector to say primary part.cFrame look vector on the negative side. So if I test the game again, and if I fly to the right and then fly up, we can see that my character no longer rotates to face the left. Now let's fix a different problem. If I jump and press F to fly, we can hear that there are no sounds as I fly around. But if I press F without jumping, we can hear footstep sounds as I fly around. So what I'm going to do is, just before we activate flight mode, I'm going to check to see if the character is standing on the ground. And if the character is standing on the ground, I'm going to make the character jump. So I'm first checking the floor material that the humanoid is standing on, and if the floor material is not air, that means they're standing on the floor, I'm going to change the humanoid's state to jumping, which is going to make them jump, and then I'm going to wait for 0.1 seconds to give them a chance to get a little bit off the ground before I activate flight mode. We now have a small problem because we're waiting for 0.1 seconds, and that problem is, while we're waiting for 0.1 seconds, there's a chance that the player may press the fly action again. And because the connection still has not been set, connection is still equal to nil. So the next time they press the fly action, while we wait for this wait to finish, it will go into this section a second time, and it will activate the flight mode 2 times, and that will cause the heartbeat connection to be overwritten and will cause problems. So to prevent that from happening, I'm going to set the connection up here as soon as we get into this function before the wait. I'm going to say connection equals true, and at the very top I'm going to check to make sure if the connection is equal to true, and if it is equal to true, I'm going to exit out of the function. So I'm going to say if connection is equal to true, then return. And I'm also going to make sure to pass the pass value like so. And so now if I enter flight mode while standing on the ground, we can see that my character jumps, and it will prevent the footstep sounds from appearing. Let's now add a custom flight animation. You can use any animation you like, but I don't have an animation, so I'm just going to steal an animation from my character. And if I come into this animation script, I'm going to take the swim animation, and I'm going to copy this animation and then stop the game and come to my local script and paste into this script the animation, and I'm going to rename this animation to animation. I'm now going to get a reference to the animation inside of the script. So I'm going to wait for child animation, and then I'm going to load the animation onto the humanoid, and that's going to give me an animation track. I'm then going to set the priority of the animation track to movement. And now, just after I've enabled the align orientation, I'm going to play the animation track. So I'm going to say animation track play, and when we disable the align orientation, I'm going to stop the animation track. And so now if I enable flight mode, I start my animation, which is the swim animation, and if I stop flight mode, I exit the swim animation, and if I start again, I have the swim animation. And let's finally add a trowel when the character is flying. So inside of my local script, I'm going to create a trowel, and I'm going to change some of the properties. I'm going to set face camera to true. Inside of transparency, I'm going to press this button with the 3 dots, and I want the transparency to be fully transparent when it starts. Then I want it to quickly become opaque. So I'm going to set this to 005 and 05, and then I want the trowel to fade out as it gets to the end. I'm then going to set enabled to false. I'm going to change the lifetime to 1, and for the width scale I'm going to press the button again, and I want the width to start kinda compressed and to quickly expand and to then compress as it fades out. So I'm going to set this to 7.5, and I'm going to set this to 0.05, and I want this to be 0.5. Now for this trowel to work, it requires 2 attachments, attachment 0 and attachment 1. We could use 2 attachments that are in the character's model, but I'm going to create 2 custom attachments so that I can position them wherever I want. So to do this, I'm going to say local attachment 0 equals instance new attachment, and I'm going to position this attachment, and I'm going to parent this attachment to the lower torso. I'm going to do the same for attachment 1, but I'm going to slightly position it to +2 instead of -2. I'm now going to get a reference to the trowel, and I'm going to set the attachment 0 and attachment 1. So I'm going to do attachment 1 as well, like so. And all I need to do now is make sure to enable the trowel. So after we start playing the animation, I'm going to say trowel enabled equals true. And when we exit flight mode, I need to make sure to stop the trowel. So I'm going to set an enabled equals false. And so now when I fly, I get a trowel behind my character. We can see that the width starts slightly small and then increases and then decreases as it gets to the end of the trowel. And when I disable flight mode, the trowel stops, and when I enable flight mode, the trowel starts again. It's also possible to add textures to your trowel. So if I come into workspace and select my model and find my fly script and find my trowel, I can open up the toolbox and I can search for a texture, and I can find a texture. I'm going to use this rainbow texture here. I'm going to copy the asset ID and I'm going to paste it into the texture. So we should now see that I have the rainbow texture. I can change the texture mode from stretch to static, which will make the rainbow texture look like this. I can increase the texture length from 1 to 20. So now my trail looks like this. And if I wanted to, I could change the texture mode to wrap, which will make the texture look like this. Thank you for watching my video, and if you have any questions, feel free to leave a comment down below.